Hello and welcome to Geology 101 Section 502. Today we'll be discussing shorelines with Group 12, presented by Elizabeth Arriens, Hailey Cortina, Thomas Friesenhahn, Jimenez, Daniel Offield, Hannah Schweitzer, Todd Walker, and Jackson West. The shoreline and ocean waves, the coastal zone, basic features of the coastal zone.
Howdy everyone, my name is Jackson West, and today I'll be talking to you about the coastal zone. Now, first and foremost, we have to answer what exactly is the coastal zone. Well, the coastal zone is the area where the land meets the sea, and this area actually acts as an interface for the land, the sea, as well as the air. Another thing about the coastal zone is it is a constant changing area. And this happens due to a couple of different processes, one of those being erosion. And this erosion occurs from the constant beating of the waves against the shoreline, and the shoreline erodes as a result. This erosion can happen at different speeds. For example, in Cape Cod, Massachusetts, there's actually a very fast level of erosion due to the shoreline being made up of poorly consolidated glacial sediment. But at Point Reyes, California, there's actually a very low rate of erosion. And this is because the shoreline is made up of tall bedrock cliffs. Another factor that affects the coastline is the sea level. Well, the sea level rise can actually push back the shoreline, which causes features that were previously on land to be now at the shoreline. And these features can be made from a diverse range of geologic processes, such as glaciation and volcanic activity. And actually, most shorelines have experienced some level of sea level rise due to the melting of glaciers from the last glacial maximum. And the next more important factor that affects the coastal zone is human influence. Humans have a strong desire to live near the shore, and this is actually seen in the fact that close to half of all humans live within about 100 kilometers of a shoreline. Now, they tend to build structures on the shore, which affects the features of the shore. Another way humans influence the shoreline is by human-induced climate change. Humans have caused some climate change through natural gas emissions and other ways as well, which have caused glaciers to melt and the sea level to rise, causing some of the changes we have talked about previously. Now, the humans don't only have an effect on the shore also, and the coastal zone also affects humans as well. Natural disasters such as hurricanes and tsunamis can pose real threats to the structures humans have built on and around the shore. Now, that's all I really have to talk about the coastal zone. Next up is the basic features of the coastal zone.
Hi, my name is Hannah Schweitzer, and I did some research on the basic features of the coastal zone. And so basically this portion was about climate change. And climate change varies from place to place, and it also varies over a period of time. So when you're measuring climate change, it usually is measured from a period of time and not just like a specific day. It has been only predicted over the past few centuries, and even the data then was not very accurate. So back then, the data was used from like natural things. There were no tools invented to help measure like weather or the climate change. So it was very inaccurate, and it was just like a prediction. Before the instrumental tools that we use today, people use natural tools to record the climate change patterns. And this study was called paleoclimatology. And then proxy data is indirect climate change evidence that is collected over a period of time. So basically what I was saying earlier about measuring climate change before the tools were used, that's what proxy data is. So these include measuring or like using tree rings, ice cores, ocean floor sediments, oxygen isotopes, coral, and fossil pollen. So you use these and you can measure the time and the period, like the period of time that the weather was at that like specific time. Another method used to measure climate change is by gathering sediments from seafloor, which contain tiny shells of microorganisms. These microorganisms contain information about past ocean conditions. And then fossilized calcium carbonate shells illustrate the composition of seawater from when they formed. The oxygen levels are O18 and O16 along the length of a core, and they obtain a record of climate over the time interval represented by one segment core. And when something is labeled as O16, that can show that it's from the ocean water, and when it's O18, it was either on land or in the ocean, or went from land to the ocean or evaporated, and that's like considered rainfall.
Hurricanes, the ultimate coastal hazard. Coastal classifications: Atlantic and Gulf Coast, Pacific Coast.
Hi, my name is Hailey Cortina, and today I will go over coastal classifications. So there are generally two types of categories that geologists use to classify coasts based on the changes that occur within sea level. They're known as the emergent and the submergent coasts. Emergent coasts occur where sea level falls relative to land level. An example of these emergent coasts are those in which regions that were once buried beneath great ice sheets, or also known as glaciers. When glaciers were present, their weight depressed the crust, and when the ice melted, the crust began gradually to spring back. Consequently, prehistoric shoreline features may now be found high above the sea level. In submergent coasts, this is where the sea level rises relative to the land level. In contrast to the examples shown in emergent coasts, other coastal areas show definite signs of submergence. Shorelines that have been submerged in the recent past are often highly irregular because the sea typically floods the lower reaches of river valleys, flowing into the ocean. The ridges that separate these valleys, however, remain above sea level and project onto the sea as headlands. These drowned riverlands are known as estuaries, and they characterize many coasts today. An example of these would be along the Atlantic coastline, the Chesapeake and Delaware bays. These are large estuaries created by submergence.
And on the topic of hurricanes, we've grouped the Atlantic and the Gulf Coast together because they share some of the same geological phenomenons that pertain to hurricanes. The Atlantic coast officially spans the length of the eastern United States, from Massachusetts to Florida, the southern tip of Florida. And their hurricane season is usually from June, and it ends in November. And what kind of makes the Gulf Coast and the Atlantic coast similar is that they both have barrier islands along the coast. And when a hurricane is to come through, those barrier islands is what takes most of the blow from the hurricane. And once the hurricane hits those islands, they decrease in strength very rapidly as they go inland. Same thing in the Gulf Coast. It goes from southern Florida, where the Atlantic coast ends, to southern Mexico. And that is what we know as the Gulf of Mexico, or the Gulf Coast. And their hurricane season is pretty similar, June through November. And two noticeable hurricanes that we've had in Texas would be Hurricane Harvey in 2017 and Hurricane Hannah in 2020. Some stats on there about those: a Category 4 versus a Category 1, and the damages caused by those, 125 billion versus 1.2 billion. And again, the Atlantic and the Gulf Coast were grouped together because of these barrier islands that they share. And when talking about hurricanes, these islands are very important because as they hit the island, the hurricanes decrease in strength very rapidly, and they move inland with much less severity than they would if there were no islands and it hit the mainland straight away.
Okay, Pacific Coast. Well, the Atlantic and Gulf Coasts are characterized by the presence of gently sloping coastal plains, with wide beaches and depths increasing steadily out to sea. The Pacific Coast is characterized by narrower beaches, usually directly adjacent to steep cliffs. This is due to the higher level of tectonic activity on the Pacific Coast, leading to greater uplift than what would be found in the Atlantic or Gulf Coasts. The tectonic activity on the Pacific Coast means that the gradual erosion, like what causes the gentle slopes on the East Coast, is only a small factor in the overall shape, as the uplift affects the topography significantly more. As sea level rises due to global warming, it can be expected that the erosion of the West Coast shorelines will increase, due to the water being able to reach further ashore. However, due to the already high cliffs and irregular coastline, The rise in sea level is much less obvious compared to the effects on the east coast.
Stabilizing the shore. Hurricane, the ultimate coastal hazard. Profile of a hurricane. Hurricane destruction. Detecting and tracking hurricanes.
Howdy, my name is Daniel Offield, and today I'm going to be covering the section Hurricanes, the Ultimate Coastal Hazard. To live on a tropical island is so appealing to many because the weather is usually very consistent with little variation day to day. The breeze is warm, the temperature is steady, and tropical showers can be expected but are typically brief. With all that said, the surprising reality is that while this island life is almost perfect for the majority of its days year-round, some of Earth's most intense storms are also expected to hit here and carry on far beyond the tropics. Whirling tropical cyclones are considered the greatest storms on the planet. Their wind speeds can exceed over 180 miles per hour occasionally. And in the US, they're called hurricanes. In the Western Pacific, they're called typhoons. And in the Indian Ocean, they're called cyclones. Hurricanes can bring casualties, and the majority of them are somewhat infrequent, meaning that the majority of hurricanes don't bring a large number of casualties, yet the ones that are very devastating can bring a high number. And an example of this in a historically lethal hurricane would be Hurricane Katrina back in August of 2005. This hurricane wrecked the Gulf Coast of Louisiana, Mississippi, and Alabama. While many fled the storm, there was a great number of casualties still. Lethal hurricanes such as these are also notorious for causing great financial loss and turmoil for the cities that are affected. Hurricane and tropical storms leave our coastal cities vulnerable, and yet we still find over half of the US population living within 45 miles of a coast. This reality leaves millions at risk, and with the rising sea levels and the reality that coming hurricanes would wreak havoc, both in terms of casualties as well as financially, we can say without hesitation that hurricanes are the greatest coastal hazard that we face today. With regards to the profile of a hurricane is a heat engine comprised of condensed water vapor. Hurricanes take a lot of moist, warm air to form, and they will continually require this in order to sustain itself. Once formed, hurricanes produce an absurd amount of energy daily, and hurricanes often form in late summer or early fall due to ideal weather conditions in that time with warm air and moisture in the air. This is why hurricane formation over cooler waters is considered rare. And within 5 degrees of the equator, hurricane formation is not probable due to the Coriolis effect being weak in that area, not giving any potential hurricane enough rotation to form. With regards to pressure gradient, hurricanes have low pressure centers, meaning that the outskirts of a hurricane have the highest pressure point, while the eye of the storm is the lowest pressure point. Pressure gradient is referring to how quickly pressure will change per unit distance. And when looking at a topographic map, isobars line, which is isobars meaning lines of equal pressure, when they're close together on these maps, that indicates steep pressure gradient as well as stronger winds. And isobars that are further apart, which is just essentially the opposite, they mean the opposite of that, meaning that is not steep, but is the opposite. And with regards to the structure of a storm, when the inward rush of a warm and moist air nears the eye of the storm, it turns and goes upward in a ring of cumulonimbus cloud towers, as our textbook says. This ring-shaped wall surrounds the eye of the storm, and this is called the eye wall. And this is where the greatest wind speeds and heaviest rainfall occurs. And surrounding this eye wall, you find curved bands that spiral outward. And close to the top of the hurricane, the airflow is outwards, creating a space in the eye of the storm for inward flow at the surface. So the eye of the storm typically is 12.5 miles in diameter and contains slowly descending air by compression, which makes this area the warmest part of the hurricane. And once again, the eye of the storm is deceiving in that the sky can appear less intimidating, and the pressure, wind, and rainfall, they all decrease. However, everything surrounding the eye is very dangerous and can be detrimental to coastal cities on a large scale. Thank you.
Howdy everyone, Jackson again. Now I'll talk to you about hurricane destruction. Now, the damage caused by hurricanes depends on a couple of different factors. One of them is the size and the population of the area the hurricane affects. A larger population or a larger area size causes increased damage. Another is the shape of the ocean bottom near where the hurricane lands as well. That can also affect the damage a hurricane deals. And lastly, and probably most importantly, is the strength of the hurricane. This strength is usually given a number somewhere between 1 and 5, and you've often heard it referred to as the hurricane's category. Now, there are three main causes of the damage dealt by a hurricane. One is the storm surge. The storm surge is the dome of water around where the hurricane's eye meets the land, about 65 to 80 kilometers wide, and it increases the sea level near that point. Now, this sea level rise is also associated with some increased wave activity, which causes tremendous damage in the area where the hurricane lands. The next important cause of damage is wind damage. This is often the most visible, as it scatters debris everywhere and is very clearly seen in damage. It can also cause some buildings to collapse, particularly mobile homes are in danger. And while the wind damage is not quite as severe as the storm surge, it is way more widespread and so can cause nearly as much damage. The last important cause of damage in a hurricane is rain and flooding. Now, rain and flooding can be seen up to hundreds and hundreds of kilometers away from where the hurricane lands. It is very widespread. For example, in September 1999, Hurricane Floyd caused about 2.5 million to evacuate from Florida up into the Carolinas and even further beyond that. And this was actually the largest US peacetime evacuation up until that point in time. So it is very clear that rain and flooding can pose a significant problem to those affected by a hurricane. Those are the main points of hurricane destruction, and that's all I have for you.
Now that we have discussed the damages that a hurricane can cause, let's discuss the tracking and detecting of hurricanes. The predicted path of a hurricane is called the track forecast. One of the methods geologists use are satellites. Instruments aboard a satellite to estimate wind speeds within a storm. Satellites are used to identify areas of extraordinary cloud development called hot towers in the eye wall of an approaching hurricane. We also use reconnaissance aircraft, which provides visual observations and meteorologic, hydrographic, and geographic characteristics. Coastal radars senses sub-20-meter boats within the sea cluster environments. Sea clusters refers to the signals returned from the wave and turbulent rough sea surface. Remote data buoys with sophisticated computer models, meteorologic monitor, and forecast storm movement and intensity. Data buoys are used to detect the atmospheric pressure, wind speed, direction, air temperature, rainfall, and wave period and height. Both the reconnaissance aircraft and coastal radar collect complements or verifies data from ships or weather satellites. Our bibliography includes citations for the PowerPoint template from Slides to Go, presentation during the lecture presented by the professor at Texas A&M for Geology 101, Section 502, and the textbook Earth: An Introduction to Physical Geology, 13th edition.